Okay, we're going to do the left side of the level 3 of our trigonometric relations. Okay, so it says construct a 10, 6, 8 triangle. So I'll do that. Get a ruler. All right, can we get a ruler with centimeters? Yes, awesome, lucky day. All right, so 10. Well, 10 is from here to here, so this will be our 10 centimeters. And then, of course, in order to make the rest of the triangle, we need to measure arcs. So I'm going to do an arc of 8 centimeters from this side, and an arc of 6 centimeters from this side. And it is fairly predictable that we should end up with a right triangle. After all, when you put 6, 8, and 10 in the Pythagorean theorem, it comes out equal. So it should look like a right triangle. And as expected, it's basically a pretty valid right triangle. Okay, now to do that little trick, AB equals 10. So we know this is AB, but we got to figure out which one is A and which one is B. So this is 6, this is 8, this is 10. So AB touches the 10 is AB and CA is 8. So see, I see the 8 here and I see the 8 here. So the 8 and the 10 both touch A, so this has to be A. The 6 and the 8 both touch C, so this has to be C, so therefore this must be B. So measure of angle B equals upside down protractor, just kidding. Measure of angle B equals, it looks like about, supposed to be 53. This time I got 55, but I'm going to put 53 because I know that's the answer that you actually should get. All right, the sine of B is opposite over hypotenuse, so that's 8 over 10, which reduces to 4 over 5. Cosine of B will be the adjacent over the hypotenuse, 6 over 10, which reduces to 3 over 5. The tangent of B will be opposite over adjacent, 8 over 6, which reduces to 4 over 3. Wow, that's the whole problem. We're done. Cool. All right, second, construct triangle PQR where AB equals 2 square root of 2, BC equals 4, and CA equals 2 square root of 2. Okay, this square root of 2 number is a big indicator that what we have is a 45, 45, 90 triangle. All right, so we have to use that special 45, 45, 90 construction. All right, I'm going to start with a 4-inch segment, so that's from here to here. By the way, somebody basically destroyed this ruler's ability to make straight lines. Thank you very much. Please don't do that. They're not your rulers. Seriously, guys, it's kind of rude. All right, so then we make the original segment. What we do is we make a perpendicular bisector. So when we line up our perpendicular bisector, this is now 2 inches and this is now 2 inches. This is now a 90-degree angle, so that's good to know. When I set this equal to this distance, it's also equal to this distance, meaning that the location where it intersects here is the same distance as this location, meaning that we have 45, 45, 90 triangles. In other words, this is a 45, 45, 90, this is a 45, 45, 90, and more importantly, this is a 45, 45, 90. This was 4 inches, this is 2 square root of 2 inches, this is 2 square root of 2 inches. All right, so the sine of C, well, we got to label things first. So BC is 4. In this case, it doesn't matter which one is B and which one is C because these are congruent, so it doesn't matter. This, of course, will be A. So the sine of C is 2 square root of 2 as the opposite over 4 as the hypotenuse. 2 square root of 2 over 4 reduces to the square root of 2 over 2, which is no surprise because we've kind of discovered that the sine of 45, so I wrote that in the wrong place, but guess what? It's the same answer. The sine of 45 is always the square root of 2 over 2. The cosine of 45 will be the same thing. Just to illustrate, the adjacent from C is 2 square root of 2, so 2 square root of 2 over 4 is the same as what it was when we had the sine, so no surprise. Tangent, opposite over adjacent. Well, what we get here is 2 square root of 2 over 2 square root of 2. Whenever you divide the same thing by itself, you're left with 1. So that's no surprise. If you like 1 over 1 for that answer, that's not a bad answer. I kind of like it, actually. And then the measure of angle C, well, if I did everything right, it should be about 45 degrees. After all, that's what this construction is named. Yeah, 45, pretty much. 45 degrees. We'll take it. Okay, that was that one. Not so bad. Next, construct triangle PQR with PQR equals 4, or sorry, PQ equals 4, QR equals 2, and RP equals 2 square root of 3. That square root of 3 is another indicator number. We see that most frequently in 30, 60, 90 triangles. So the way we're going to construct a 30, 60, 90 is we're going to do an equilateral triangle and we're going to bisect it. So I'm going to do an equilateral triangle at S equals 4 inches. And then I'm going to bisect that triangle to get me a 30, 60, 90. So I'm working on my equilateral triangle. There we go. So if this is 4 inches, these all have to be 4 inches. All right, now I need to bisect it. In order to save space, I think I'm going to do my bisector over here. It doesn't really matter because right now they're all the same. But I do my bisector in this direction. And what that does for me is it bisects the entire triangle. So this angle is now 90. This is 60. This is 30. I don't need any of this anymore. It's actually not part of my construction. Here's my 30, 60, 90 triangle. So if PQ equals 4, QR equals 2, and RP equals 2 square root of 3, then this must be RP, and this must be PQ, and this must be QR. I look at this point. It touches the 2, and it touches the 4. So what touches the 2 and the 4? Well, we got PQ and we got QR. Q is the letter I see twice, so that must be Q. What touches the 2 and the 2 square root of 3? Here's the 2, here's the 2 square root of 3. We have QR and RP, so this must be R. And by process of elimination, this must be P. Okay, so the sign of Q, opposite over hypotenuse. We got 2 square root of 3 over 4. 2 square root of 3 over 4 reduces to the square root of 3 over 2, which we've actually gotten really used to this. That's the sign of 60. The cosine of 60 will be adjacent over hypotenuse, 2 over 4, which reduces to 1/2. We're very used to this pattern by now. The tangent of Q will be equal to the opposite over the adjacent, which is 2 square root of 3 over 2, which reduces to square root of 3. If you want to put it over 1, I kind of like that. It's probably a good idea. All right, now sine of P. Here's P over here. Opposite over hypotenuse, 2 over 4 will be 1 over 2. As we've noticed, the cosine of one angle is always equal to the sine of the other angle, so that's no surprise. We can also predict that the cosine of P is going to be the square root of 3 over 2 because that's the same as the sine of Q. And then the tangents are reciprocals of each other. So this can be 1 over the square root of 3, which needs to be rationalized. So we get the square root of 3 over 3. What you notice is that with these patterns, the work just gets faster and faster and faster. All right, so measure of angle R was 90, measure of angle Q was 60, measure of angle P was 30. So sine of 30, well, sine of 30 is always 1/2. That's our conjecture. It seems to be true every time. I'd say that's a pretty strong pattern. Cosine of 30 seems to always be the square root of 3 over 2, and the tangent of 30 always seems to be the square root of 3 over 3. Seems pretty basic. Sine of 60 always seems to be the square root of 3 over 2, which again, as you notice, is the same as the cosine of 30. The cosine of 60 always seems to be 1 over 2, which is the same as the sine of 30, so this seems pretty strong. And the tangent of Q is the square root of 3 over 1, which these are sort of hidden reciprocals of each other. They are reciprocals, it's just hard to notice at first. Anyway, I don't think it's that hard. Practice hard. Should be no trouble. Good luck. Thanks. See you in class.